And I would like to welcome all of you today to the third meeting of the Wheelchair Testing Centers. Thank you for joining us. Just received an email from Miriam and Nicole. They are actually our two new members, and apparently they're having a couple issues joining us today. So if you guys can give me 1 minute, I will just forward this information for them so they are involved with us. Okay, awesome. So before we start today, I would like to kindly ask you if we can switch our names as we have done in the past. So I would like you to please go to participants. You're gonna click on the right side on more, and then you're gonna change your name, and we're gonna use our first name, the country we are located at, and then the institution or testing center we are representing today. Okay, so we're gonna take a couple of minutes for us to do that. Okay.
What's the order that you want again?
So we're gonna go to participants and then click more. We're gonna use our first name. So in this case, it would be Stephanie/USA/ISWP. So for you, it would be Peter, USA, and Beneficial Designs. Yep. So you're gonna see me on two different usernames right now. I'm gonna keep the one without the camera as my name, but please feel free to send me a chat via, a text via the chat on either computer. I am just using two different computers at the moment, so that's why you're seeing that information right now. Okay. I would also like to start introducing our new members. These are Miriam and Nicole. Miriam is the lead engineer from UMTRI, and also Nicole Orton, who is the senior engineer. I'm not completely sure if they have been able to join us yet, but I would like to go around the table and maybe do a quick introduction. So let's start with Dr. Perman. Why don't you tell us a little bit about yourself and what have you been doing so we can go around?
Start with who?
With Dr. Perman.
Sorry, thanks for the reminder there. John Perlman, University of Pittsburgh and ISWP. And yeah, for many years, I chair I convene the working group at ISO that focuses on most of the manual wheelchair testing. And we do and have developed several tests here at Pitt to support testing around the world.
Thank you. Can we go next with you, Dawn? Can you tell us a little bit about yourself?
Yeah, this is Don Schoendorfer. I'm the president and founder of Free Wheelchair Mission, an organization that's been around for getting on to 21 years, giving out wheelchairs for free for the developing world.
Thank you. Can we get a word from you, Peter?
Hello, this is Peter. I'm Peter Axelson, and I'm the leader of Beneficial Designs. We're out near Lake Tahoe in northern Nevada in the United States, and I run a wheelchair test lab, and I'm secretary of the RESNA, the U.S. RESNA Wheelchair Standards Committee, and I also lead a air travel standards committee that's developing specifications for wheelchairs for air travel. Thank you.
Thank you. Maybe can we go next with Elora, please?
Hello, I am Elora. I work in the Institution Nationale des Invalides and more specifically in the SERA. Actually, I'm very new to the SERA and I am actually replacing Alain Pawlowski, the responsible of the test laboratory of wheelchairs. So here I am.
Well, welcome and thank you for joining us today. Nice to meet you. I see you are with someone else today. Would you like to introduce yourself as well?
Hello, I'm Álvaro Altamirano. I am a researcher in SERA also. So I work in the prototyping department. I'm here with Elora, who is our new arrival. So I'm very happy to be here. Thank you.
Thank you. Welcome. Let's start now with Jim Watson.
Hello there. Yeah, my name's Jim Watson from Cranfield Impact Centre in the UK, and we perform sled tests on wheelchairs. Just recently, we've been doing a lot more testing on powered wheelchairs. Is what we've been doing more so of, but also involved in performing some looking towards doing some of the static tests as well on wheelchairs.
Awesome. Welcome again. Now let's start with Alex Delazio. She's also the first time who's joining us, so I would like to welcome her to the group, and I would allow you to now introduce yourself.
Hi there, everyone. My name is Alexandra Delazio. I work as a research engineer for the Department of Rehab Science and Technology. I help manage a lot of our knowledge translation efforts for the Rehab Engineering Research Center on wheelchair and cushion standards performance. So we've been sending out a lot of messages about our upcoming webinar series, about giving thanks for standards, and just spreading the word that all of the efforts that we're doing on wheelchair and wheelchair cushion testing. So I'm really happy to be here to say hello to everyone and excited to participate today in the meeting.
Where are you located, Alexandra?
I'm in the so I'm in Pittsburgh, in the University of Pittsburgh. So I'm right
Okay.
here in Bakery Square with John and Stephanie.
Thank you. I also see we have a new member, Sanjoy Oinam. Would you like to introduce yourself? Maybe we can continue with you, Bill.
Hello, good morning, everyone. My name is Bill Ammer. I operate Ammer Consulting. I'm a test facility outside of Pittsburgh, Pennsylvania, here in the United States. I'm the chairman of the RESNO Wheelchair Standards Committee. I work a lot with Peter Axelson. I also sit on WG1, WG10, and WG11 on the TC173, SC1 ISO standards committees. Thank you.
Thank you, Bill. We also have Nancy today. Nancy, would you like to introduce yourself to the group, please?
Sure. Hi, everyone. I'm Nancy Augustine. I am at the University of Pittsburgh working with Dr. Perlman and Stephanie on the International Society of Wheelchair Professionals grant. I help administer the grant on a day-to-day basis, making sure all of our programs are running smoothly and keeping our funders informed of our activities. So very happy to be here. Thank you.
Thank you, Nancy. And finally, last but not least, I would like to introduce to the group to Miriam. Miriam, she, as I mentioned before, she's the lead engineer. So would you like to introduce yourself to the group, please?
Hi, everybody. My name is Miriam Maneri. I work at the University of Michigan Transportation Research Institute, and I've been doing research in wheelchair passenger safety for about 30 years. Our work, including doing research and developing new test protocols. We also run a sled impact lab that runs tests per the standards, particularly ISO 7176 Part 19 and RESNA WC19. And then we're also pretty extensively involved in developing standards. I'm the chair of the RESNA Committee on Wheelchairs and Transportation, and I'm one of the US experts for WG6, which is the mirror committee for COWAT. Glad to be here.
Thank you, Miriam. Well, I wanted to welcome all the members to the group today. I also appreciate everybody joining. I know the time zones are quite different, especially for those who are in California and in other countries. So thank you so much for joining. I believe I have Ms. Dean Mubaiwa from Shonaquip. So I apologize for that. You are one of the presenters and I completely skipped your name. So I apologize. Would you like to introduce yourself to the group, please?
No, it's okay, Stephanie. My name is Dean. I'm from Shonaquip in Cape Town, South Africa. Shonaquip is a company that manufactures pediatric devices, mobility and posture support devices. I'm the design engineer there, but right now I'm focusing on testing of wheelchairs and accessories.
Thank you. I also see that Bob Appleyard just joined. Bob, just to give you a quick update, we're introducing each other to the group. So if you would like to give us a word about you. I don't think we can hear you, but I see your microphone is on. Yeah, 1 second, please. Well, maybe we can do Bob's introduction a little bit later, but I would like to continue with the schedule. So today we're gonna do a quick meeting. We're gonna go over 2 main tests. Now that we have completed the introductions, I just want to share with you some key information. And today we're gonna go over the static and impact testing from Bill Ammer. And the second presentation is gonna go over the double drum. And we're gonna have Dean Mubaiwa from Shonaquip SE, social enterprise. And from now on, I'm gonna give Bill the chance to share his cameras. I know he's gonna be sharing some interesting views from his shop. So before we start, does anybody have a question so far? No? Okay.
I'm in, by the way. I had a problem with connections. Sorry about that.
Go ahead, Bob.
Yeah, hi, good. Sorry, I'm late. Dreadfully sorry. Bob Appleyard from the UK. Yeah.
Thank you. Bob, sorry, Bill, would you like to start with your presentation? I think you're
Let me get to my other station out there. Just give me a second.
Sounds good. Yeah. So in the meantime, I will just give a little bit of information to the rest of the group. As you know, we are collaborating with each other, and the fact that we started today with the static and impact testing was because of the need that Shona from Shonaquip mentioned. They're interested in adding this specific test to their testing lab, and that's why we were connecting with you as members. And we received information from Bill that he would like to be part of this contribution. So that's why he's going to be presenting. And maybe towards the end, we can include some information on how we can collaborate with each other and how can we support Shonaquip to complete this testing in their facilities. Okay.
Can you see me, Stephanie?
I can see you very well. I'm going to stop sharing and put you as a spotlight. There you go.
Excellent. Thank you. Not sure that you can see the whole test rig here. I want to run through the equipment first. This is the rig that I use for doing my static and impact testing. It's basically just a metal superstructure. It's stuff that I've welded together on my own here and designed. I also use this small ramp for my static stability testing, so it has the ability to tilt as well. See if I can get you a shot at the at the top here. So basically it's a superstructure. I have a motor system at the top that will allow me to move this crossbar up and down. And what I've got is inside the uprights here, I have an Acme thread that allows me to move this crossbar up and down. I can use that then to apply forces when I need to that are vertical type forces. I also, for things like armrests where we have to apply forces that are not vertical, I've actually taken an old seat actuator and I use it on top of the superstructure there. I'm going to put that on here now.
Bill, I don't know, can you still hear if we ask questions while you're doing this?
Yes.
How do you measure load if you have this Acme thread that's driving that down? So how do you dial in the load that you need? Where's the load cell or load measuring system?
The load cell, let me grab it here. So I've got a load cell and a meter that I use to read the forces. The load cell is set up to attach to the bottom of this ram here. And then I have in order to apply the loads, I have loading pads that are specified in the wheelchair standard, different size bars that allow me different lengths. So that I can apply loads to footrests and armrests, things along that line. Does that get it for you, Tom?
Yeah, perfect. Thanks.
Okay. So I'm going to grab a wheelchair here. So for clarity today, I'm not going to use the hold down on the wheelchair. I'm just going to show you how I set up to apply the loads. So for instance, doing an armrest downward force. So the standard tells us that this load for an armrest downward has to be applied at a 15-degree angle outward, and that's to simulate somebody sitting in the chair and pushing down on the armrest. That force wouldn't be perfectly vertical. It would be more out to the side. So we apply it at a 15-degree angle. And we would use a protractor to apply that load. Can you see that? So the standard tells us where on the armrest we have to apply that load in a forward backward position. The mount for the actuator actually slides back and forth on there so that I can pivot it anywhere that I want. Also, this whole superstructure here is on a clamped rail, so that if I need to move it forward and backward, I can do that. So I would adjust for my 15-degree angle with the protractor there, and instead of bringing this superstructure down, that would skew the angle of the load. So I would use the actuator here to apply load. I don't know whether you can see that moving or not. That's moving the wheelchair. So it would be an up and down load, and I would read that on the test meter here. This plugs into the sensor. So we would do armrests up, down, footrests up, down. Well, that's all the actual static forces that we would apply. If it had push handles, we would test that in an upward direction. Some wheelchairs have hand grips on the back. There would be a static test to check for that. And I have another cable system that I use so that I can make a horizontal pull on the hand grips if I need to. So one of the things that I find interesting about the standards is that it allows us to not test things if they don't meet certain requirements. So for instance, if you have armrests that are removable that would come out if you lifted up on them, then you don't need to test those for upward forces, simply because you wouldn't be able to pick up the wheelchair from them. One of the things that I do here is that if I had to test this armrest for an upward force, it would pull up like this. But in my opinion, someone could still grab this upright here and try to lift the wheelchair. And so I test those as well, and enter those results into my test report. The standard tells me that on an upward force on an armrest, I have to place, the load has to be at a 15-degree angle outward. But if someone was trying to lift this wheelchair by this armrest here, the force would be more vertical. And so during that test, I actually modify that a little bit so that even if the armrest does fold up out of the way, I believe it can still support weight. And so there are times that my test results will show a vertical pull on that armrest, just to make sure that they're solid enough that if somebody lifted that wheelchair by that armrest, that it would still be stable. One of the other tests that we do is, I'm going to try and adjust the camera down a little bit here.
Yeah, that looks better, Bill. Thank you.
Just one question. Sorry, can you hear me?
Yes.
Was that a question?
No. The wheelchair is just kept left, or you have some fixed or holding system for the wheelchair during the test of the armchair?
There is a holding system. I mentioned previously that I'm not using
sorry.
that, just for clarity right now.
Okay, sorry. Thank you.
Okay. So for instance, on this footrest, we're supposed to do a downward force on this footrest. We're also supposed to do an upward force on this footrest. Now, the standard tells us that if it folds, that we don't have to do that. But this footrest, I don't know whether you can see it in the picture or not, it has a hole through it. Can you see that? So in my opinion, somebody could fold this footrest up and actually pick up on it. And so when I test for upward forces on the footrest, if it has that capability, I do that as well. There's nothing to stop someone from grabbing the sides of that footrest and lifting the chair. So those are some things that I want to change in the standards. But for right now, there are limits as to what you can do. So for instance, if I wanted to do an upward on the footrest, I would change the loading pad to a hook, and I would use a loading strap to attach to the footrest. A couple of the other things that we do are impact testing. And so there are a couple of devices that we use in the standard for doing that. One of them is an impact pendulum. This is specified in the ISO and RESNO wheelchair standards 7176-8. This is about 22.5 pounds, if I remember correctly. And if you can see here, there's a threaded part here that allows me to adjust the pendulum. There's a specification in the standard that tells us where the center of this mass has to be and what length it has to be from the pivot. And then also we have our impact tester for the backrest. Yes, this is a soccer ball. It's filled with 55 pounds of lead shot, about what, 22 kilograms of lead shot, and we strike the backrest with this. So let me set this up really quick here. So there are specifications in the standard that tell us where on the backrest that it has to be struck by the pendulum. Get this up here just a little bit higher. So then the standard tells us for this impact, it tells us what angle that we have to drive that pendulum at. So we would use the protractor on the shaft of the pendulum and then pull it to that angle and then release. And again, I'm not using the hold downs on this. So that would be a backrest impact. My only misgiving on this test is that we only do it one time. I think there are some tests in the works where we would do this more like a fatigue test. But right now, this test is only done once. So it's one strike of the backrest with the pendulum. So we also strike the casters with a pendulum. And the standard tells us that we have to strike that at a 45-degree angle. So we need to either move the pendulum or move the chair so that we can do that. I actually have another one of these pendulums that has the weight turned 90 degrees so that the center of the pendulum contacts the center of the tire. I'm a little high on this one, but the other pendulum has this turned 90 degrees, so it would be more on center. The other thing that you're allowed to do in the standard is raise the chair up on blocks so that you can hit that center weight. And again, we would use a protractor to determine what angle we're going to strike the chair with. And test is done one time. Now we also strike the footrest in a longitudinal direction. So it would basically be the same setup, striking the footrest longitudinally, and then we also strike it laterally. So we can work the chair in here. Excuse me. And the angles are all spelled out in the standard, and they're based on the weight of the chair plus the weight capacity of the mannequin that we use in there. That is basically static and impact. Are there questions, or would you like to see more? Or can I explain the equipment any further?
Yeah, I have a question, Bill. So you said this is happening just one time, right?
Right.
So I assume this test is just going to be like a pass-fail, or do you report if anything specifically broke, and how would you report this test?
Right. It would be a pass-fail. So obviously, if it still works afterwards, it's going to be a pass. But if you break something, there are times when I've had there's like a plastic cover over the caster sometimes, and in order to hit the caster, you actually have to either remove that or break it to get it off. My feeling is that if the caster itself is functional, that it should be a pass. That a broken plastic cover on something should not constitute a failure as a failure of the caster. Does that explain that well enough?
Yeah. So just a crack is still a pass.
Right.
Okay.
Anybody else?
Yes, Bill, I have a question. Can you hear
Sure.
me?
Yeah.
I think so.
Yeah. What if the caster, or maybe somewhere in the subassembly there's a bending? To what extent would you then say this is acceptable and this is not?
My feeling is that if the operation, the safe operation of the chair is not inhibited, that you would consider it a pass. So obviously, if you strike a caster with a pendulum and it bends the caster stem, that's not acceptable. But like I was explaining before, if it's some cosmetic cover that is broken, and you don't inhibit the safe operation of the chair, then it should be a pass. And I think we need to do a better job of explaining that in the standards.
Yeah, I would add that in this test, you know, the pass fail is whether after you're done with the test, whether the chair comes back to normal, right? So just because the armrest might bend a little bit, so long as it doesn't bend plastically and deform over the long term, then it passes the test. And Bill's point about shrouds and other plastic things makes sense, right? So sometimes you might have like a power chair that has a shroud around the caster. And I think officially you could fail that on the impact test if there's a little crack after you impact it. But realistically, you're not putting the individual at any more danger after a little crack occurs. And so you can interpret it, you know, and be flexible on things like shrouds. But if the caster bends or the armrest bends, or if you do the impact that Bill showed on the backrest and a bolt breaks, for instance, like sometimes, you know, the bolts that are positioning that backrest may be weak, or they may have just had too small of a bolt, and so the bolt will shear off. Then that's a failure, because that could really put somebody at risk if that occurred in practice. Is that fair, Bill? That's sort of neat.
Yeah, that's a great explanation, John. Thank you.
Hey, Bill, it's Peter. Can you hear me?
Yeah.
Yeah, can you show people how you use your unistrut there to secure the chair? Just sort of conceptually.
I didn't pull all of that out.
But I mean, you can explain it by.
There's a system of.
Show your parts where you secure it to.
Well, it actually ties into this upper strut and this lower strut at times. It's excuse me. It's basically a box that I can put some weight in and then anchor it so that the chair doesn't move. I have never been a big fan of the system that's outlined in the standard. My feeling is that we should be allowed to use tie downs to anchor the chair. Let me get the box.
I think while Bill's away, I'll add, and I think he can follow up, but what you're seeing there, you know, in terms of the platform and the unistrut, is really simple construction of sort of universally available, you know, steel extrusions. And so, you know, so I think it's just a message that this doesn't require a high-tech laboratory or machine shop to actually construct something like this.
Dean, I know you guys were interested in adding this to your facilities. Is there something you would like to ask to Bill after seeing what he has explained?
Pretty much most of the questions that people are asking are the ones that I was interested in. One other question, but I think Bill answered it, was on how to attach the wheelchairs when you're doing this test, especially at 45 degrees to the casters. And yeah, because the good thing is the standard pretty much explains what needs to be done, but sometimes when it comes to theory, to practice, it's a little bit different from theory, if that makes sense.
It is. The system that's outlined in the standard is pretty vague. It says it's allowed to touch, but it's not allowed to I forget the wording that's used. So basically they're saying it shouldn't touch the wheelchair, but it has to hold the wheelchair in place. It's really vague. It's always been a point of contention for me. I think we should be, if we're doing it that way with that type of a restraint, then we're not actually testing, let's say we're impacting the backrest. There was a version in the previous standard where we would use the mannequin in the seat, and we were told to remove the back of the mannequin when we were testing the backrest. And just the remaining weight of the mannequin was supposed to be enough to hold that seat. My feeling is that if we are, let me see if I can move this. My feeling is that if we're going to impact this backrest, in order to do the worst case, we should be able to restrain the rest of the chair. And a lot of times that's what I end up doing, because the chair, with the way this restraint system is configured now in the standard, when you hit this, the chair still moves. My feeling is that the rest of the chair shouldn't move if we're testing the backrest. Same with when we're testing the footrest. The rest of that chair shouldn't move. So we should be able to restrain the chair, say with a couple of ratchet straps over the casters here, would hold that in place so that when we strike this, we're actually doing a worst case test on this footrest and not allowing the chair to move backward when we strike it. The same with the lateral. So it's the hold down system in the standard is not specific. It doesn't say use this or use that. It tells you how it should react. But I use this box, and I can put weight in the box to help restrain the chair, and then some struts from the top and or bottom to keep it in position. I don't know. Pardon me?
Oh no, I'm just agreeing to what you're saying. Sorry.
Oh.
Okay. Yeah.
This is, see if I can get this in front of the camera right. This is called Unistrut. It should be available just about anywhere. It's a 2" by 2" steel channel. And you can buy these nuts for it so that the nut will slide in, and once it's turned, it locks into position. Let me see if I can show this. So the nut is basically shaped like a T, and when it goes in, when you turn the bolt, it locks in and allows you to tighten the bolt. That's what most of this is put together with. The corners are all welded though. That was something that I decided to do, but you could basically build this and bolt it all together if you wanted to. Peter, I don't know whether that covered your question or not.
Yeah, I think that was helpful to explain. This kind of a challenge when we go to test is how to hold the chair for each test.
I think it's something that needs to be changed. Any other questions?
We have a question in the chat. Jim posted, do you measure displacement during the static test? Dr. Perman responded that it's not required on his experience. You just want to determine whether the part of the chair has deformed after the load has been released.
Oh, about displacement? No, there's no provision to measure. Are you talking displacement of the part? So like if we put pressure on an armrest, do we measure how far it bends? No, we do not do that.
Yeah, that's right. Yes. Yeah. I just wanted to know whether there was a way that you could compare then one chair to another chair, or if if people wanted to know how close they were to failing, whether they could go back and reference
So
it.
how close you are to that elastic limit? No,
Yeah.
the standard doesn't account for that.
The standard just specifies the force to be applied. So you do need some way to measure force so you know that you're applying the
Yeah.
force.
And it's
So on that question, on the force, is the load cell which you're using there, then it's a tension and compression load cell, is it?
yes.
Yeah.
And this particular one has a 500-pound capacity. I do have a larger one that goes to 750, but I find this does about 90% of the wheelchairs that I need to do this on.
Okay.
Bill, I have one more question. Do you find this test being requested frequently, or is this a test that's done usually in the manufacturer's testing facility or in-house?
Well, for something like a 510K where they're looking for FDA approval, I will generally do this test. We also have something in the United States referred to as PDAC, which helps to code the chair for its appropriate use. The manufacturers are allowed to do the static and impact and the drum and drop in facility because those tests are a little more expensive. And so they're allowed to do those tests. I do this on maybe a third of the chairs that I get here.
Thank you. Does anybody else have another question for Bill?
Let me make one comment about this, that I think, when you think about Section 8, from my perspective, Section 8 and Section 1 are the most important from a safety standpoint for manual wheelchair users, that this is part of Section 8. So we always look at durability and fatigue. That's common, and that I know Dean is going to present on the double drum work. But this static load and impact is really important to identify weak links in the chair. And and there's sort of the FDA and the regulations here in the US are one thing, and there's naturally a lot of politics of why you don't have to do independent testing for these parts of Section 8. But I think in reality, to really prove out and be confident in the reliability and the performance of a chair, I would encourage everybody to do all of Section 8, including these static impact tests.
It can tell you a lot about the chair, and it tells you not only about components, but as the chair as a whole. Imparting a load into the backrest not only affects the seat, but the way the seat is mounted, what it's mounted to, the substructure on the power base frame. So yeah, I think they are relatively important.
Thank you, Bill, for showing all of this to us. And I hope some questions have been clarified so far. I would like to now switch our gears and introduce Dean as our next presenter. He is from Shonaquip Social Enterprise, and he will be presenting about the double drum. So Dean, whenever you are ready, I will be switching now to you as a spotlight. And I also want to
sorry, Stephanie. I still had one more question for Bill.
Yeah,
sorry about that.
Go ahead.
Yeah. So I wanted to ask a question. It's pretty much the same questioning about the impact test for hand rims. The passing criteria, is it a fail pass criteria? Because clearly when you do impact tests for hand rims, they plastically deform. So it becomes a situation where to what extent should they deform?
I've had a few that took maybe a small dent in the surface. I don't know that I've ever had one really deform significantly out of round that you couldn't use it. Usually they're anchored pretty well to the wheel. And if that's the case, I see sometimes where there are 8 or maybe even 10 anchor points for the hand to the wheel rim. Obviously, if there are less anchor points, they would have to be more robust. And if there are less anchor points, the hand rim itself would have to be more robust so that it wouldn't bend. You have that supported basically at 2 ends. Well, if you spread those 2 points apart, obviously the hand rim has to be a little tougher to withstand that. So I think what you want to look for is the number of contact points or the number of attachment points before you start testing. I generally do that.
Yeah, because what I noticed is most wheelchairs, especially here in South Africa, the hand rims are made from aluminum. So once you do the testing, it's pretty much that they will not break or crack, they will plastically deform. So it's just, the acceptance criteria to what extent, is acceptable. Yeah. Thank you so much, Bill.
I don't know that there's anything spelled out in the standard that says, this much is acceptable, this much is not. And perhaps that's something we need to work on.
Sorry, I have one question to add on to that. Is that okay, Nancy? Oh, sorry, Stephanie.
Yeah,
Bill.
Hi, Shona.
Hi, sorry I'm so late. I was held up in another meeting. Bill, do you have any experience on testing hand rims where they're integrated into the wheel and there are no connection points? So for example, quad type push rims, and the testing processes related to that.
I don't know that I've ever done one of those. Sorry, I've got a real lack of experience there. About a third of what I do is manual wheelchairs. Usually I'm testing powered wheelchairs, and so I don't really see too many hand rims here. I apologize for that.
No, it's interesting because it's something we haven't thought to test, but now we want to look at how to build a test for that, because I think as more and more new types of or innovation emerges around wheelchair design, we need to have flexibility in the testing processes. So, yeah.
Shona, I don't know that the testing approach would be very different if it was an integrated hand rim versus, a detachable. The impact requirements, are the same. Is like you're trying to reproduce a circumstance of a wheelchair user, running their hand rim into the door frame of a door as you're going through it. And so whether that hand rim is part of the wheel or not, you want to try to expose it to the same kind of circumstance, which is possible with the test rig that Bill just showed us.
Okay, thanks.
Does anybody would like to add something else? Okay, then Dean, it's all yours. I'm gonna set a spotlight for Dean/presentation. That's the one we're going to use for your camera, correct?
Yep.
Okay, so I would like to just encourage everyone else to please click on the top right corner where you see view and click on speakers so you can see Dean's camera is much larger. Okay.
Yeah. I still don't have access. I'm trying to share my screen.
Okay, let me check now. Can you try again?
The one called Dean presentation. Okay.
Is it allowing you to share now? Okay, cool.
Yes, it is. Awesomeness. Okay, cool. So I I'll be presenting on the fatigue test for fatigue strength test. Usually when it comes to presentations, I'm a bit nervous, so I tend to eat on my words. So if there's anyone who doesn't hear clearly what I'm saying, please feel free to just stop me and then I'll explain a little bit better. So I was going to do what Bill did, but when it comes to the 2-drum roller test bed, it takes quite a lot of time because you have to set up the test bed, the dummies, and yeah, so it's quite a lot. So I made a pre-recorded video of a presentation showing the setup procedures. So pretty much this video is more for educational purposes on our side, because we would like to get as much feedback as possible from you guys, especially if there are like questions or suggestions, or feel free to critique basically. So enjoy. Firstly, the test fixture is weighted without the test dummy on top. Then soon after, the test dummy is placed on top of the test fixture to measure the overall weight. After obtaining the weight of the two, the test dummy is loaded with metal slabs so as to give it a weight of 100 kilograms. After recording the total weight of the test fixture and the test dummy, then the center of gravity of the test dummy and the test fixture is determined. The method employed is the balance method from ISO 7176-11, Annex A. The next procedure is the test bed setup, with the first step measuring the distance between the center of the rear wall to the center of the front casters. The selection and sampling of the test specimen is done exclusively by the manufacturer, who then provides a record or document showing the criteria followed in the selection and sampling process. The measured wheelbase is then used to set the distance between drums, so that the center of the wheels is set directly above the center of the drums. The next step is drum slats selection, and the height of the slats is obtained from the standard ISO 7176-8. Drum speed measurement is the last step for the test bed setup, and the speed of the reference drum is measured using a tachometer. After recording the drum speed, the revolution counter is set to 0. Once the test bed is set up, the next procedure will be the wheelchair setup, where the wheelchair is attached to the test bed using procedures from ISO 7176-22 setup procedures. Where the attachment arm specifications are obtained from ISO 7176-8. The longitudinal stiffness of the attachment arms is 100 newtons per meter, and the attachment arms are attached so that they are parallel to the ground or within a tolerance of plus or minus 10 degrees. And next, the test dummy is placed on top of the wheelchair. Firstly, the loading pads are attached to the wheelchair. This includes the foam cushion in blue of thickness 30 millimeters, and the loading plates, which is the torso and the tire loading plates, which are set up according to the standard ISO 7176-11 setup procedures for test dummies. Next, the foot plate is adjusted so as to give support to the dummy legs. The next step is to add weighted blocks to the test dummy to give an overall weight of 100 kilograms. The weight proportion of the torso to the thigh is obtained from the standard ISO 7176-11. Soon after the test dummy is secured, the safety system is connected. This is a system that cuts off power to the electric motor in the event that the chair or the dummy are off center position.
Sorry.
Frequent checks are carried out to make sure that everything is in position before testing. Once that has been done, the test bed is then caged off for further safety reasons. Then finally, the chain guard is also put in place. After running a series of safety checks, the test is now ready to begin. Yeah, so pretty much that's it. The rest of the video is just the test bed running. I didn't want to waste much of people's times.
Thank you, Dean. That video was amazing.
Yeah.
It was a great work. It was
Thank you so much, guys.
also how you explained, even from the beginning, from the test dummy setup to the end. So congratulations on that. And also your video editing skills were right on point. I know you were working. Well done.
Thank you so much, Stephanie. Thank you so much. Yeah.
I would like to open now for questions for Dean and also feedback. I know they're looking for feedback. So we have some test centers that are doing this test as well. So if you guys would like to provide any feedback to Dean, I know all are welcome.
Dean, that was a really great video.
Thank you so much.
Very well put together. Do you test at the capacity of the wheelchair? So you would, let's say if your wheelchair was 125 kilogram capacity, would you test at that weight?
Yeah, so according to the standard, it's pretty much what the manufacturer says.
Okay.
So this specific model is produced by Shonaquip, and according to the government tender they have, it has to carry 100 kgs worth of yeah, a test dummy. So I tested with 100 kgs.
Okay.
Yeah.
Do you Dean, do you run that all night, or do you turn it off? Like how much monitoring do you do of the test when you run it?
So we try to do overnight, but due to safety reasons, and also we do have some issues here and there with load shedding here. So we have now divided the 200,000 cycles into into 5. So we run it from 7 a.m. in the morning until 5 p.m. in the evening for 5 days, from Monday to Friday, and then we will reach 200,000 cycles, unless the manufacturer specifies more than 200,000 cycles. Yeah.
And are you, can you just share like how many chairs are you testing, like say in a given month? And are you only testing like Shonaquip chairs, or what range of different products are you evaluating?
So right now our capacity is still low because we had to relocate from the space we had. So this is actually quite a new space, but it's still small. We need to move later on. So we don't have much capacity. But when it comes to testing, we're testing anything, even from other local manufacturers, other manufacturers as well. So yeah, that's why we had to request more help from Bill about the impact testing, because we actually want to introduce another test station, which is for the impact test. That was also requested by our local manufacturers of wheelchairs as well. Yeah.
Great. Thanks.
I hope if it's okay, I also had questions for you guys, because whilst I was doing this, I came up with a few challenges. The first one was the determination of the center of gravity. I followed everything from the first procedure and the standard, but the numbers were just not coming exactly as the standard required. So I don't know if I could actually have, for instance, Bill, I don't know, or anyone else who has a test laboratory where we can have more of this discussion on, calculations and determinations of COGs.
I don't think we can hear you, Bill.
So the, do you say you're having trouble locating the center of gravity, or getting
Yeah,
it?
so I'm having problems with following the procedure exactly as it is in the standard, but I'm not getting the values that the standard requires. So for example, the location of the center of gravity and y-axis would be from 235 millimeters plus or minus 35, but I'm getting something like 400. So it's just one of those things where, I think it might be small problems, but I don't know quite exactly what's happening there.
It took me, I think when I first built my mannequins and tried to set up all of my CGs for the different weight classes, it took me about a week's worth of time of trial and error to get those in the right place. And it's a matter of moving the weights around within the structure of the mannequin.
Yeah.
I'll send you some pictures of mine. It looks like your weights are about the same size as mine.
Yeah.
So, for instance, the torso section of mine is actually two weights deep.
Oh, I see.
And I will get some pictures to you probably through Stephanie. But that allows me to get, it sounds like you're not able to get the center of gravity far enough forward. Is it?
Yeah.
Okay.
And also low enough. When it comes to height-wise, my center of gravity is usually twice the recommended center of gravity, so which is quite confusing. Yeah.
The second row of weights in the torso section will help you a lot with that.
Oh, yes. That's, yeah.
I will will get you some pictures of mine. I think I'll even send you my layouts for my weights, because I use not only weights, but I use some spacers to move those weights around. So for instance, in the thigh section, a lot of times I'll have 25 or 30 millimeters of just spacers, and then start the weights. That will help to move the center of gravity forward a little bit for you.
Okay.
So
Thank you so much. So, yeah. Yeah.
Sorry, can I ask a question, Bill? Something that's been bothering me about this, and maybe a lot of other people might have some input, but in terms of weight distribution for children versus adults, because a lot of our personal testing is child related or pediatric related. The other part that's really a question for me is around dead weight. So the weights we're using really are dead weights. They have no give in them, whereas a human body isn't a dead weight. It's not the solid jarring weight that we're using. So has anybody ever experimented with a more dynamic weight material than lead weights? Water or sand or chicken food or something. I mean, what could we use that is more relevant to the type of thumping that happens in a chair? Because this jarring thumping, I don't think it is giving a realistic outcome. Thanks.
One of the things that the standard tells us when we do the drum test is that we should lock the knees on the mannequin. I've never agreed with that. I think the knees should be unlocked so that the legs will actually move up and down a little bit. The other thing that I've tried is I've tried spring loading the torso section on the hinge so that it will give, instead of restraining the torso section with a strap around the seat. I just restrained the thigh section, and I use a spring on the side of that goes from the torso section to the lap section that allows the torso to move back and forth a bit. The only problem is it's really cumbersome to use, and if you have a chair, let's say I'm using a mannequin for dynamic stability, I have to take all those springs off if the chair has a tilt or recline on it. But I've played with it, and it's really complicated to do. So I feel your pain, Shona. I'd like to see that more realistic too, but I don't know a way around it right now.
Could be something. It could be something for Dean to work on, couldn't it? There, Shona. You know, maybe if Dean was to run a series of tests on one product, say your Mubaiwa wheelchair, and with the solid mass, and then was to do it perhaps with, I don't know, bags of wheat or something like that would, have a little bit of flow, with, body mass proportions sort of set somehow in that wooden block, or maybe devise a variation on the wooden block, and just see what the difference is in terms of durability. Might be worse, might be better. I wonder. It could be interesting.
Now, I know for testing of we built an emergency evacuation chair to be able to get people from informal settlements in sort of very steep and rugged areas down to a road. And we use bags of chicken feed, which is maize, basically, and which has some fluidity and it moves around. But I was a bit nervous to try with concepts like that for ISO, because obviously it's it's a really, it's a different way of looking at it. But in reality, if you're looking at client-centered design, the actual testing is not realistic. So
Yes,
yeah, we would love to experiment, but is that something that would be useful to other people, or is it just something that I'm holding on to?
No, I think it would help the knowledge. It would increase the knowledge pool, Shona. I'm sure that John would agree. Working group 1 would be, I'd be interested to see the difference in results. And if there was a means of improvement, I'm sure that it would be, people would be open-minded.
Yeah, I mean, there's been over, sort of the evolution of ISO and trying to develop test methods, where there are no test labs. There's been, several different attempts to look at that, not maybe formally, but more as a practical solution when, going and building a dummy doesn't make sense. So, we've seen them in India. The Whirlwind Wheelchairs folks came, developed what they called EISO, which was sort of like an extended and more practical approach, and they use bags of sand as dummies. There are different cases where different types of dummies are used. And I think one of them, I'll say, like when you're doing dynamic stability testing for power chairs, usually you have an able-bodied operator that's driving it through trying to see whether this thing tips over. And for a while we looked at, so usually that would be, usually a grad student we basically hire, to basically put in the chair and see whether or not the thing tips over under lots of different driving conditions. But we did look for a while at whether we could reproduce that through a more traditional like crash test dummy, which has, and we even changed up the stiffness of the ankle and other, where, those dummies are, 50 percentile, sort of standardized dummies, and will loosen up the knee joint or the hip joints, assuming maybe somebody has a spinal cord injury, so it doesn't have trunk control that way. And we did some testing in that way. I think maybe Miriam at Umtree can talk about, in the sled testing for wheelchairs, I believe they use a traditional crash test dummy to simulate the dynamics of the actual body. I think that these Section 11 dummies have been developed mostly for internal validity. So the dummy that Dean's using is the same as the dummy that I'm using, is the same as the dummy that Bill is using, to just make sure there's consistency internally. If we all test the chairs, we get the same results, but with some recognition that it doesn't simulate the actual, behavior of the body. I think another area that I think is a challenge here, especially Shona, when you talk about kids, is when you have extensor tone and other loads applied to the system, due to contractures and those are also in a similar way not simulated, I think, appropriately or accurately in these tests. So, but maybe Miriam can talk about talk about the dummies that they use for sled testing.
I think we've seen it in our own products where you can go through the ISO test and pass with flying colors. The chair could do double the testing, but you put a child with dystonia in the chair, and within a few months, you've already got problems. And so for me, the interface between the user and the device is not being tested. And that's our interest. That's really our interest, area of interest. And I would love to work with some of the students, for example, to come over and work with us on that, because I think that's the missing piece.
Shona, when we did all of the work on the dummies back in 2008 or whatever, and we came up with this center of gravity system. It was a big step forward for us, but it still wasn't perfect. And we're working on some things right now to make it better. But one of the places that we were really lacking was representing small people in the equations that we use to determine the center of gravity for a person, especially children. Their bodies are different. They're not little adults. Their body makeup is different, and you know, people who design wheelchairs for children find that out very quickly, that they can't just scale things down. And so if there was something that we should add to our plate as far as, you know, representing how a human being reacts in a wheelchair, I think along the lines of the children, and those smaller dummies is where we need to do some work.
Yeah, it's certainly our passion.
Yeah, certainly with transport as well, Bill. There's a point well made there. Yeah, I think that maybe when we're testing wheelchairs for use in transport, sometimes I think the proportions of the ATDs, the child occupants, really need us to think very carefully. Yeah, I'll echo that.
I just wanted to add that I think that the way to approach this problem is to go out to the field and see what sort of adverse events are happening that could be mitigated with a better test. We do have obviously these crash test dummies. They have their own limitations. But I think that maybe the most effective approach is to go out and try to better define the problem we're trying to solve, and then see how the different representations of the human can address that most effectively.
Thank you. Well, just as we're getting a little short in time, I would like to thank everyone for participating today. There's a little bit more that I would like to show you today. But first, I would like to ask to thank both presenters and also Shona for the comments you have just made. I'm going to share my screen, and I'm also going to be sharing a link via chat. So if you can please go ahead and open that link for those that are in your computers, please go ahead and open it. We're going to go to the slide number 7, and you're going to see topic of interest. So I'm going to start sharing my screen again.
Sorry, as we do that, can I ask just one more question? It's on ISO 176-22, setup procedures, selection and sampling. I wanted to know if once you are a test facility, are you then responsible for the selection and sampling of the wheelchairs that you test, or is it defined by the manufacturer and then you just get it as it is?
Was
I don't
that
know if you guys can hear me.
For Bill, or?
Oh, it's just like for everyone. Because yeah, the standard 7176-22 mentions methods for selecting a wheelchair for testing and methods for sampling. So I just wanted to know, is it the test lab's responsibility to make sure that the manufacturer is being honest and providing a chair that represents the range of model that they produce, or is it just one of those situations where we just take a chair and then it's not the lab's responsibility to actually check that the chair that is brought in actually represents like a population or sample of all chairs?
I think the manufacturer, Dean, the wheelchair manufacturer has the responsibility to select the right product. I think that as a test house, you have kind of responsibilities to conduct the test according to a given performance and make sure the quality is all right and the traceability, rah. But the actual decision lays firmly, I would have thought, with the manufacturer, and he might even test 2 or 3 samples with different setups and go with the worst case one.
You don't have that problem too much with powered wheelchairs, unless it's got some kind of a complex rehab seating system on it. But as far as manual wheelchairs go, if a manufacturer has a chair that, let's say that it's adjustable for width and seat depth, I would generally ask for one to be set up as small as it can be and one to be set up as large as it can be, and test them both.
Okay. And then one last more, I promise this is the last one. So we have a device, a model called the Madiba Buggy. I don't know if you're familiar with it, but it's pretty much like in the UK, they'll call it a pram, and the US is a stroller, but it is a pediatric device for kids with CP, and they do not, it's not a manual wheelchair. They don't propel themselves, they are pushed. So my question will become, would it be fair to attach that kind of device on a 2-drum tester using the axle, or should I connect the push rims to the test bed, if I make sense?
I would propose if you can just probably via email share the link.
Okay. Okay. Yeah, sorry for wasting people's time. Yeah.
No, it's okay.
Okay.
I also think that a good idea would be if we can add those topics that you have questions about into the slide that I shared.
Oh,
and
okay.
just rate it. So this could also become part of our conversations in the future. Maybe we can have more than one topic to discuss for this next meeting or for our future meetings. But do you think that would be better? Maybe we can spend more time in those questions as well, so you can get more.
Yeah, I think that would be best. Thank you so much, Stephanie. Thank you. Awesome.
So I would
Cool.
like to ask to the group if we can go please to slides 7 and 8. I would like to each one of you to please propose a topic of interest. This could be a test. I know that Bob was also interested in presenting about this lab test. So this would be like as an example. Dean, you can propose those questions you have here. That would be just a very quick request I have for you. And the second step would be to mark with an X on those topics that you would like to see. So let's say you were saying selection methods, right, Dean? So I'm just gonna go ahead and mark an X if I see interest. If a second person adds another topic, then I can also make a mark if I am interested in that as well, okay? So if you can please help me with that, we can also use this as part of our future meetings. Sorry, we're a little bit farther on the time, but I think it has been a great discussion with all of you and the feedback has been great. So thank you everyone for staying. Also, Dean and Shona, I just wanted to let you know on slide 6, I made some quick notes about the feedback that you guys received on the presentation. So if you need to have access to that, you can use the same link that I shared before. Oh, I really like these alternative materials. That's good. And those who have already proposed your topics, please go ahead and go to slide number 9. As you know, we're continuing to meet on the second Wednesday of the month. So I would like to ask you, when would be a good time for us to meet? Maybe the second Wednesday of January, February, or March 2022. you will be receiving an email sometime soon to see who would be interested in presenting these topics. I see that there's some interest in the test dummy for smaller people or children. Maybe this could be an open discussion, but if there's something in specific you could be interested in presenting, I'll be reaching out to some experts who have, for example, the auto seatbelt and tie down, maybe with Miriam. So please expect some emails in the coming weeks or months, okay? Don, thank you for your question. So let me know if you received the link. I'm gonna put it again in the chat for you. I think I just sent you a private message. So if you can click on that one, and then you're gonna see Google Slides. So the screen that I'm sharing right now, and you can go to slide number 7, and then you can just go ahead and edit it. Well, I see some of you are still filling that information. Thank you very much. And I also see that most of the people who have replied on the last slide are interested in meeting on the second week of February. So that would be, let me come really quick to my calendar. That would be February 9. So right before Valentine's Day. So I think it's going to be a good moment to share as a group of friends now. So I'm going to put it here in, that would be February 9. And you will also be receiving an email with an updated invitation for the wheelchair testing centers. We're going to continue to use the same link, but I'm just going to let you know you're going to receive an updated invite, okay? Thank you everyone for participating today. It was great to see you. Thank you both for presenting, and also Shona for your comments. And I look forward to see you on February 9th. Thank you. Have a good one.
Thank you.
Muchas
Bye.
gracias, Stephanie. Buen día.
Álvaro.
Thank you so much.
Thank you. Bye.
Cheers, bye.
Bye.